Okay, guys, day 5, higher order derivatives and applications. So I have 2 challenges on here. The second one is really hard, and I think I don't want to be getting you all confused, so we probably just won't do that second one. But let's take a look at the first one. So the first one is product rule, right? So I can see that I have first, right, and second. So I have first times derivative of the second plus. Now, second, now when I do the derivative of the first, I took this and I changed it over to look like this, right? Instead of, if I don't change it, I have to use the quotient rule on that, and that's crazy. So 1 over x I can change to be x to the negative first, and 1 over x squared I can change to be x to the negative second. Now I can just use my power rule, right? So negative 1 times 1, decrease the power by 1, and the same, same thing here, and that's where I get the derivative of the second. Okay, so that's just a little technique, something you want to look for instead of using quotient rule. If anyone's interested in trying this one, go for it, but it is hard because it's product rule, right? I see product rule, first and second, but then I also see that this is quotient rule right here, and there's nothing I can do about that. So go ahead and try it if you want to, and then you were evaluating at x equals negative 1. But that's a little much, so I don't want to get you too crazy. Okay, second derivative. So in order to find the second derivative, you find the first derivative, and then take the derivative again. This is used next year to determine concavity of functions. So we're not going to do that this year. We're just going to straight up learn to find the second derivative. And then next year, for any of you going into AP Calc or into, in college taking this, you would need to know it. So the notation can look 2 different ways. It can be f double prime of x, or we can say that the change in y over the change in x, but for the second derivative, we write it as such. All right, and we just say that, the second derivative. All right, so here we go. So find the second derivative. So first, let's find the first derivative. So the first derivative is going to be 28x to the 6th minus 15x squared plus 2. And then the second derivative, and you just do it again. So use a calculator here if you need to. 6 times 28, 168. Decrease the power by 1, minus 30x, and the derivative of a constant is 0. Okay, so second derivative, that's all. And then we'll use that next year to do some more stuff. Again, second derivative, so let's find the first derivative first. First derivative is 3. Second derivative, remember what the derivative of a constant is, 0. Okay, so not so bad there. Okay, let's do some more. So first derivative. So we have a little quotient rule going on. So it's bottom, d top, so times derivative of the top, minus top, times derivative of the bottom, all over bottom squared. Okay, so we do need to clean this up before we find the second derivative. So let's clean this up a little bit. So we're going to have 15x. Now, be careful when you're doing this math right here, right? How should you really do it? I would probably move the 5 to the front and make it negative 5 times 3x minus 2. Be a little easier. You do whatever you want there, but that's really the best way to do it. So we're going to get minus 15x plus 10 over, and remember, 5x all squared, so 25x squared. So still continue to clean that up. So the first derivative is equal to, so these guys wipe out, right? And you're left with 10 over 25x squared. But we can simplify that, right, to 2/5. And now watch what I'm going to do. X to the negative second, right? Move it up top, because if you leave it like that, now you have to do the quotient rule again. And we don't want to have to do the quotient rule if we don't have to. So remember, negative exponents, you go on the top written positive, or you can just move exponents from top to bottom by changing their signs, and that's from Algebra 2. Okay, so now let's do our second derivative. And we could just use the power rule. So negative 2 times 2/5 is negative 4/5 x to the decrease the power by 1. And there is my second derivative. Okay, so a little bit of yesterday's lesson mixed in with this. All right, let's do the next guy. Again, we're finding the second derivative, so I can see we have product rule going on here. So let's find the first derivative first. Change in y over change in x. So product rule is first times derivative of the second plus second times derivative of the first. Oops. Okay, so let's clean that up. So the first derivative is equal to, so let's do a little distributing. So 2x cubed minus 10 plus 6x cubed plus 9x squared. So there's my first derivative. So now let's go ahead and find the second derivative. And we're just straight up using the power rule again. So we're left with, first actually let's combine like terms first. Okay, so cleaned up, we have 8x cubed plus 9x squared minus 10. Now let's find the second derivative. Power rule again, 24x squared plus 18x. And that's it. All right, let's go a little bit further and let's do, let's find the third derivative. So we'll find y triple prime. So I did all three of these, so you guys go ahead and pause and try. There they are. And see how you do. All right, so check it out, see if you got those right. Okay, and now one last question. So this one's definitely going to be tough. Just do the best you can to stay with me. If you can't, it's okay, but give it a shot. All right, so it says, find the equation of the tangent line to y equals rad x that is parallel to the secant, which intersects the curve at x equals 1 and x equals 4. All right, so I'm giving you a little visual here so we can imagine what it is that we're doing. But again, the first thing I notice is we're writing an equation of a tangent line. So if we're going to write the equation of the tangent line, let's get organized. And off to the side, we know that we need a point and we need the slope. And we know we're going to use point-slope form of an equation. So let's get that all off to the side. So once we get in this question, we remember what our ultimate goal was. Okay, so that's what we're going to be doing. All right, so let's take a look at this. So here's y equals rad x. Remember what the square root function looks like? Now, I want to write the equation of the tangent line that's parallel to the secant. If it's parallel, we know it's going to have the same slope as the secant line. So we're ultimately going to find the slope of that secant line, which all I have are the x values. And let's look. So here's 1, here's 4. Remember, secant is going to hit twice. So I'm going to find the slope of this green line, which then is going to be the same as the slope as the tangent line because it's going to be parallel. Okay, so first let's do the green guy. So let's plug in and get our partners. So if I plug in 1, square root of 1 is 1. We plug in 4, square root of 4 is 2. Remember, this is average rate of change because it's a secant line. All right, we get our slope of 1/3. So if the slope of the green secant line is 1/3, then I know that the slope of the blue tangent line is also 1/3 because they're parallel, and we know that back from geometry. So here's my 1/3. Okay. All right, so now we are going to find the first derivative. And what's interesting is we already know what that slope is. So we know what the derivative is going to be equal to, right? We know the derivative is going to be equal to 1/3. So that's why this question is definitely more interesting and more challenging. It's not as straightforward as the other ones. We have to think about what it is we're doing. So let's find the derivative. So the change in y over change in x. Before I do the derivative, let's change over square root of x to the 1/2, so we can just use the power rule. So y equals x to the 1/2. So 1/2 times 1, keep the base, decrease the power by 1. Okay, so that is the slope machine. But remember, we already know what the slope is. That's why this question is definitely way different than any of the other ones we did. We already know what this is equal to. It's equal to 1/3. So I'm going to take 1/2 x to the negative 1/2 and set it equal to 1/3. And now we just got to solve this. And now this is just a basic, algebra 2 question to solve. I'm not saying it's easy, but it is just basic math. All right, so we want to solve for x now. So we can multiply both sides by 2, and we're left with x to the negative 1/2 equals 2/3. And then how do we undo that negative 1/2 power? We can multiply both exponents by negative 2. And we get x equals 2/3 to the negative 2nd power. And then remember, a fraction to a negative. Ooh, a lot going on here. A fraction to a negative is its reciprocal to the positive. And this is what happens as you guys get into higher level math next year in AP. All your basic like math skills have to stay with you, or you won't be able to do the ending of all these hard questions. So that's why we did so much without a calculator this year. So x equals 9/4. Okay, so we actually use the slope machine to find the x value in this question. So let's go back up. And now we have our x value of 9/4. So how do we find the partner of y? We'll go back into our original function, right? And let's plug in 9/4. So the square root of 9/4 is 3/2. So there's my x1 and there's my y1. Last step, let's plug into our point slope formula. Y minus 3/2 equals 1/3 times x minus 9/4. Wow, if you made it through that, awesome job. All right, so we're going to stop. We're not going to do 4 because that'll just be a killer as well. All right, have a good day. Bye.